Hello everyone and welcome back. In the previous lessons, we created our data section and the internal functions that we used in the modifiers in the smart contract, which we call Paypool, which I call Paypool. And now we are going to start creating our execute functions. Let's say execute functions here. Our first execute function will be add deposit address. Here we are going to have depositor. It's going to be an external function because we are only just going to use this from outside of this contract. We are going to say is owner. So this modifier is going to check if the message.sender is the owner because we want only the owner to be able to add a new deposit address. And then inside the function, we are going to say deposit addresses dot push depositor. And then we are going to emit the event. So what we are doing here is that we are first doing the thing that we want to do in this function. And finally, we are letting front end know what we are doing here. And for that, I'm going to say emit. And that's how we are going to emit events. And we will say address, edit. And the edit address is the depositor. Let's continue with our second function. Now we are going to say remove deposit address. We are going to say address depositor. It's going to be an external function. We are going to say is owner. And here we will say can deposit tokens because we want to remove the deposit address. First, we need to know if the deposit address is actually there. That's how we check this with this modifier. That's why we created it. And also we need to pass a parameter here. We are going to say depositor. It's going to a little bit more tricky than the one before, but don't worry, it's just a little bit more. The first thing we are going to do is we are going to say index to delete here. First, we are going to find the index to delete. And then I'm going to create a for loop here. Let's say uint I equals 0, I smaller than deposit addresses, I plus plus. We didn't say length is smaller than the length, not the array itself. So the first thing I want to say, every time you go through an array, is we are just spending some gas fee. So we don't want to go through these arrays or do these kind of operations that much. So if the operation time is on, then we don't want it that much. We want more of like O1, which is basically no time. So again, for the demonstration, this is just going to work fine. But in your actual professional smart contract, you may want to come up with different solutions. Now here, I'm going to check if deposit addresses I is equal to depositor, then we will say index delete is equal to I, and then we will break the loop. After the for loop, we are going to create another for loop. I'm going to say uint I equals index to delete. I is smaller than deposit addresses dot linked I plus plus. So here the idea is we are going to find the index. After we find the index, we are just going to override it with the next one. And then we are going to shift everything to the left a little bit. And at the end, we are going to have a duplicated final and we are going to just pop up the final element. Let's say deposit addresses I equals deposit addresses I plus 1. In this smart contract, I'm assuming that we wouldn't have that much of a deposit addresses, let's say 3, 4, maybe 5 at max. Because if you have 1,000 different deposit addresses, first of all, it's going to be very hard to manage. You are having 1,000 different deposit addresses depositing tokens to your Paypool. But the second problem is that every time you want to remove a deposit address, you are going to make a longer and longer and longer writes. And as you can see, we are making a write operation here. We are actually changing some data. And for one function call, you will have at least, let's say, if you have 1,000 different ones and you want to change the 13th deposit address, then it's going to be a problem because after 13, you are just going to change all these 900 something addresses. So again, I'm assuming that you won't have that much of an address anyways. So here I'm going to say deposit addresses pop. We are going to pop the last one. And finally, we are going to emit the event. I will say address removed, and we are going, yes, we are going to pass the depositor. Again, the first thing that we did, we found the index that we want to overwrite or we want to delete. Then here we shifted everything from that index, starting from that index, we popped the last one, and then we emitted the event. Now let's go with the next one. So with the next one, we are going to say function deposit. These addresses are actually depositing some tokens. First, we are going to check if they can deposit some tokens. I'm going to pass message.sender here, and it's going to be a payable function. Every time we get the payments as tokens, we are going to assign this function with payable keywords. Inside this deposit, I'm going to say total balance is plus equal to the message.value. So I'm incrementing total balance here, and then I'm just going to emit the event, and the event was deposit. This is the depositor, and message.value is the amount. Message.sender is the deposit address. Again, it's a very simple function. The next one will be retrieveAllowance. It's going to be an external function. So this is where the owner is retrieving his or her tokens. It's not for the ones who is retrieving their allowances. So that's why it's signed with its owner. And we are going to say non-reentrant here. So this is actually why we have this import and why we are inheriting from Reentrancy guards. So we are using this non-reentrant modifier so that we would be safe against the reentrancy attacks. Inside this, we are going to get, first I'm going to say the balance is equal to the total balance. Next, I'm going to say bool success, and we are going to have something more at the right hand side of this tuple, but since we are not going to use it or we are not going to make use of it, I'm going to keep this empty, so we are just getting one variable that we want. On the right hand side, we are going to say owner.call, and we are going to say as the value, we will add balance and then empty parentheses. And this is going to transfer the tokens, transfer the ether to the owner. If this operation is successful, inside this tuple is going to be a true. So now we are going to check it. Let's say require success. And if there was a problem, we are going to say transfer failed or retrieval failed, whatever you want to say. And then I'm going to say total balance is equal to 0. And finally, I'm going to emit the event funds retrieved. The recipients will be owner, and the amount will be balance. We got the balance here because I want to use it at the end after I say total balance is equal to the 0. We actually transferred the tokens and we checked if this transfer was successful. Then we said the total balance is equal to 0. And finally, we emitted the event. And that's how we are going to create functions resistant to reentrancy attacks by saying like bool success with this kind of call. And after checking this, and finally, you need to use this non-reentrant. So there are other ways. This is just one way. And I have to say that you need to research a little bit more if you are going to use these kind of functions in your professional Solidity smart contract. But for the time being, I think this is just a good precaution. Now let's move on with the giveAllowance function. So here we are going to have the amount that we want to give and the user you want to give allowance to. It's going to be an external function. Only the owner can call this function. And we are going to say require total balance is more than the amount or equal to the amount. We don't want to give allowance if we don't have enough tokens. And here we are going to say there is no enough tokens inside the pool to give allowance. I think it rhymes a bit. I love when it rhymes. Now that we know we have enough tokens to actually give it to someone, then we are going to say allowances user equals amount. We are going to say total balance minus equal to amount. And finally, we are going to say emit allowance granted, and we are going to put the user and the amount here. Now, if you look at this function, as you can see, we are checking if the total balance is more than or equal to the amount. And here we are saying total balance is equal to the total balance minus amount. So here Solidity automatically checks if there is an underflow or an overflow. So it's going to make sure that this is not negative. But we already know it is not negative because we make the check here. Making this check again is going to consume actually more gas. For that reason, I'm going to say unchecked here. Inside this unchecked, I'm going to put this total balance. We are using unchecked here because we are already making sure that the total balance is more than the equal of the amount. So we don't need to check here. And since Solidity was checking automatically, we said, okay, do not check it since we already handled it for you. And now let's say function removeAllowance is going to be address user. You always know if the color is not correct. External is owner. Got allowance. I'm going to pass the user here. We are going to say allowances user, and it will be equal to 0. And we are going to emit the event allowance removed user. And our last function is, let's say, allow retrieval, and I think it's correct now. It's going to be an external function, and we are going to use this function to actually retrieve allowance. We're going to say got allowance message.sender. So we are checking if the message.sender has the allowance, because if they don't have the allowance, how they gonna retrieve it, right? And we are going to say non-reentrant with the same ideology before. So inside, I'm going to say amount is allowances message.sender. And again, we are going to say bool success message.sender.call. And inside this call, we will say value is equal to the amount. And finally, end parentheses. And let's check if it was successful. It's the same thing that we did before. We got the amount and we transferred the amount. We checked if the transfer was successful. And now we are going to say total balance. And sorry, we don't need to say total balance because it's not even inside the balance. If we check here, once we say give allowances, we actually incremented the amount from the total balance. It's not inside the total balance, so we don't need to say, okay, let's make total balance less. But we will say allowances message.sender is equal to 0. Now we got no allowance, sorry. And finally, we are going to emit the event. Once retrieved, the recipient is message.sender and the amount is amount. All right. I think that's it for now. And if we check the Solidity compiler, it compiles just fine. So in the next lesson, we are going to test this contract. I will see you on the next one.